In my previous videos, we explored MLflow and understood how powerful it is for experiment tracking, model management, and building production-ready ML systems. But in real-world companies, MLflow is rarely used in isolation or in localhost. It is usually deeply integrated with platforms like Databricks or maybe Azure. And this is where things become incredibly powerful because Databricks gives you MLflow built in, no installation, no setup, and even no configuration. So in this video, I'll create a brand new Databricks account using the free tier, show you what compute resources you get, what you can do with the free account, and most importantly, how MLflow is tightly integrated into Databricks. We will create a notebook, run an MLflow experiment, log parameters, metrics, and models, and then see exactly where everything appears inside Databricks. I'll also show you how collaboration works on Databricks, how to add users, create compute clusters, and assign compute to different users. By the end of this video, you will understand how MLflow actually works in real enterprise environments. So I hope you are excited. Let's get started. Okay, so the first thing that we want to do is we want to create and set up our account on Databricks. So I will navigate to databricks.com and I will navigate to the login page. Under the login page, we will have to create a new account, and for that you can use your Gmail account or any other emails that you might be having access to. Okay, so let this page load. It is taking surprisingly low amount of time, but let's wait. Okay, so I don't want to use my existing account. I'll just log out, and now you can see I'm getting several options. I can continue with my email, or I can continue with Google, or I can continue with Microsoft. I'll choose this option, continue with Google, and I will try to use a brand new account which I haven't used before. So I'll select this one. Now it will ask me bunch of clarification and confirmations. So I'll just continue because I trust Databricks. Now, after this step is over, it will try to ask us to set up some, I guess, clusters because essentially Databricks runs on cloud, right? So you can attach your existing cloud, or you can basically work with. Okay, so you can see what will you use Databricks for. So you can use it for personal use, or you can use for basically work. Okay, now you can get a free edition, or you can just start a trial with Express setup. So I'll select the start trial with Express setup, and let me also try changing my Wi-Fi. 1 second. Okay, so I'll just change my Wi-Fi really quickly. Give me a sec. Yeah. So yeah, so now it is basically going to ask me the location, because in the backend, Databricks is going to set up certain things like servers, compute options, and all. So I'll just select my nearest location. Maybe let's select India for now. I'll continue with it. It's saying solve this puzzle. Obviously, it will make sure that I'm human. Okay, but I am human. So I'll just click submit. Verification complete. Now let's wait for it to complete. Now in this 14 days trial, it is going to give you some accesses, like you can have serverless compute. It will be a premium kind of access, and you can essentially create notebooks, create compute instances, all those things you can create. So this is the interface that you get. Now what I want to show you in this video is I want to show you this lower left section, because that's where MLflow features are integrated. Although MLflow is tightly integrated with all of Databricks, but if you come here, you will see these experiments, you will see these features, models, and serving, and even the UI also, you can see the UI is also basically completely taken from the MLflow's open source models, which I had been showing you for the past couple of videos. So as you can see, you can go to experiments and you can see all those experiments that you have created. Now the question arises, how do you log things here? Because in the local setup of MLflow, what you used to do is you used to create runs or create experiments in your maybe scripts or notebooks. So you can continue with that here as well. I want to first of all go to this compute option, because to be able to run your script locally, you had local Python installed, but here you will be relying on the compute provided by Databricks. So I'll come here to the compute, and on the compute you can see serverless starter warehouse. Now this warehouse has been provided for free for at least 14 days. You can try it out. So this warehouse is something that you can attach. Now what does it mean to attach it? So whenever you are running some script or some notebooks, you can attach this serverless warehouse. So I'll just come to my workspace. Now workspace is basically a container of all your files and notebooks and everything. Okay, so I'll come here and I'll just go to create, and I'll select this notebook option. Now once I select this, so you get this really nice and sleek notebook interface, which I really love, because you see it's quite user friendly and it looks minimal and professional. Okay, so to be able to log things in MLflow, obviously you would need MLflow support. Okay, so I would like to import MLflow. Now to be able to run this, I have to attach the serverless compute. So I'll just click on serverless GPU, and now I can basically run this script. So let me run this. Let me allow this. One second. Let me somehow this is not loading. Yeah, so now it's connected. So now let's import the MLflow. Okay, so our MLflow is loaded. Now the common workflow is that you have a training script using maybe any package such as sklearn or maybe PyTorch, and you log things, right? But for now we will just simulate whatever we could. And also you see this auto completion that Databricks is offering. So AI is integrated, coding assistant is integrated within Databricks, so you can just use it. But for now I'll just not use it. So I'll just manually type start run as run, and now I will just, one second, I just ran it, which is going to throw an error. So what I'll do is I'll just log a metric. Okay, and I could have optionally also created a experiment. Let's create an experiment in the top cell. So I'll MLflow dot create experiment. I'll name this experiment as Databricks YouTube demo. I'll just run this, and here it's saying an experiment name must contains an absolute path. Oh, I see. I forgot it. So I'll just accept it and run. And here in place of this, one second, I'll just, let's run this and let's see. Parent directory does not exist. I think we need to grab the directory here. Somehow it's not working. So I'll just do one thing. I'll import OS and OS dot get current working directory. Okay, so workspace. So I'll just grab this email, this path, and I'll paste it here. Okay, so now if I run this, okay, so I should be able to get the experiment. Okay, so now after the experiment has been created, we will be using that experiment, and now let's log something. So I'll just try to log some parameter called theta. I'll log it as 360. And if I run this, now the moment I run this start run, it automatically detects it, and it basically is telling me that you can go into the experiment in MLflow to basically see this run. So I can go into the experiment, I can open this in new tab, and under the experiment, I would be having my experiment Databricks YouTube demo. And as in the local setup, you might have seen, if you have seen, if you have watched my earlier videos, it asks us to basically check the experiment type. So I'll just go ahead with machine learning. And now in the runs, one second, why no run is logged? Okay, one second. If I come here, oh, I see. I got it. So what happened was, when I started this run, I did not basically uh, provided the experiment ID here. So, and that is why that run was logged into a default run. Okay, so if I run this now, and now if I refresh this, we can see in the Databricks YouTube demo, we are able to see this run name. Okay, so this is not a MLflow tutorial. This is a tutorial about how you can use Databricks to do experiment tracking, to do whatever we have been discussing for the last bunch of lectures. Now I want to talk about briefly some of the I feel which are cool features of Databricks managed. First of all, you can do collaboration in a very seamless manner, and everything about user management and all is managed by Databricks. Now this can be done even with the local MLflow setup, but the problem with that is there is lot of overhead and operational expense. So what you can do is, you can come here and you can navigate to settings, and under the settings you will see this identity and access. So currently from the email that you have logged in and set up this account, you are kind of a pseudo user, so you are a admin. Now you can manage users, you can manage service principals. If you have worked with cloud, you would understand that service principals allow applications to talk to softwares in a and it allows to authenticate those applications in a automated manner. So I'll just come here and go to users. Now what I can do is, I can add users by their email. I can invite them to basically work on this workspace. And not only that, I can have multiple workspace. I can create more workspaces. Okay, so now if I go to users and if I go to add new, I can type out the email. Let me type out one email. Maybe I'll just type out my personal rahul.gmail.com. So if I add it, okay, I think since with this account I already have got one Databricks account set up, so that's why it's not a new user. So you get the idea. The moment I sent out the mail, I will get this kind of invite. One second, let me show you. So this is the kind of invite I will be getting. Join your team on Databricks. This person is inviting you, and if you click on join, you will be able to join them on their basically on their workspace. Okay, so with that said, these are the things that you want to do. Obviously, the account that I've set up is basically comes with a 14 days trial. After 14 days, you won't be able to access anything. But yeah, so one important piece which I wanted to discuss was this user management, and then there is this compute option. Now there are in the compute option, you have got options to create computes. So you can have, let's say if I click on this manage, what you can do is you can manage access policy for the compute. Okay, you can navigate to this compute and you can create a compute. So I can go ahead and create a SQL warehouse, and in the SQL warehouse I can select the size, and size directly is linked to the performance of the server, or in the Databricks and Snowflake terminology, these are known as warehouses, but they are essentially compute instances. Okay, Although warehouses, when you hear the term warehouse, you might think it's a storage thing, but no, it's not a storage, but rather it's compute cluster, you can say. And you can say here scaling, you can set what will be the minimum number of instances, what will be maximum number of instances. You can set the cluster size and things like that. Okay, so you can create it. Not only create, let me create it really quickly. Small instance, and after creating it, you can attach it to some user. So I can manage permissions. So I can maybe do add people, since currently I don't have any users added in my workspace. I'm not seeing any results here, but you get what I'm trying to say, that the moment you add one user, you can basically add them and give them access to this compute, and they can then use it. Now the next thing, after talking about users and compute, next thing that I want to talk about is how do you install packages. So if I come here in the workspace, if I come to my untitled notebook, so currently you were able to import MLflow because MLflow is tightly integrated already with Databricks. But what about maybe other packages that you might not have access to? So for those packages, what you could do is you can insert the code, and you can do something like pip install. So but first let me show you what happens if I try to import OpenAI, or maybe from OpenAI import OpenAI client. Okay, so if I run this, it's saying module not found error. Although if you notice, something interesting is happening. The moment I try to import OpenAI, it is suggesting me to basically do this OpenAI.autolog, so that all the OpenAI traces will be automatically logged. Anyways, so let's install this package. So if I run this, it will be installed on my serverless compute, and after that I should be able to use it. So let's now run this, and now I'm not getting any error. So I should be able to now load the not load but connect to the OpenAI client, and I should be able to use it. Okay, so there are tons of features. It is very difficult to cover all of them in 16 or maybe 20 minutes video, but I wanted just to give you a taste of what is possible with managed Databricks. It's awesome. If your organization or you don't want to manage all the setting up of MLflow locally, or maybe deploying that open source MLflow, it's wonderful. So yeah, so I think that would be it. Thank you so much for watching this video. There would be a lot of interesting stuff which are coming related to MLflow and Databricks on my channel. So stay tuned, subscribe for more content, and let me know if you want to see any specific topic gets covered. Thank you so much. Hi everyone. Let's start talking about experimentation and runs in MLflow using Databricks. Now, before I talk about experiments and runs, I would like to talk about few convention changes that we follow. Not follow, but rather we have to follow these conventions because we are now on Databricks. What happens usually, what is your workflow when you are working as a solo developer on MLflow, is you install MLflow on your local machine using maybe terminal, and then what you do is then you try to start the MLflow server, and you try to create some backend store and artifact store. Now there are a couple of options. You can either set these stores as local location, or you can set them to remote location. So you can have a SQL database that you can set for backend store. And for those of you who don't know what backend store and artifact store are, to summarize, a backend store stores all the experiment and run metadata, whereas artifact store large files such as large models and Python files and things like that. Okay, so what usually we do when we are doing MLflow locally is we try to set up the artifact store to either local location or some remote object storage such as S3 or or maybe Azure Blob Storage. Okay, so with that said, let's get started with the MLflow on the Databricks. So I have to come here, and on here I see this new option. I can click on it and I can create all the different bunch of things that I wish to do on Databricks. Now, Databricks is a very, you can say, complex and uh, comprehensive piece of software. So rather than covering all of that in one video, let's go ahead and create a notebook that we want to use for our MLflow demonstration. So I'll just create this notebook, and I can come here and I can rename this notebook. And the UI is quite minimal and seamless, and it works quite wonderful. So what I'll do is I'll create this notebook as experiment and runs. Okay, so before you run anything, you need to attach the server on not a server, but rather a compute instance that you will be using to run this notebook. So I will create I will select this serverless option, and I will select this serverless GPU. This seems like some sort of bug wherein if you just keep clicking on it, it won't start, but it will throw this error. But now you can see it has started, because we see this green icon here. Okay, so what we do is we import MLflow, and after the workflow is that after importing MLflow, you start one experiment. So you can have an existing experiment, or you can create an experiment from scratch. So let's navigate to the left, and let's navigate to the experiment. So I'll open this experiments tab in a new tab, and here I see no experiments got created right now. So what I can do is I can set create one experiment. Now here something is different than what we do in the that local setup. So in the local setup, what we can do is we can simply create something like demo experiment. We can name anything that we wish to do, but it won't create the experiment. Rather, you need to provide the full path of this full path of where this experiment would lie. Now, how do you get that path? So what I can do is I can import the OS package, and I can print my OS current working directory, and this would give me the path that I have to basically append before it. So I can just get rid of this, and I can grab this string that I've got. So I'll just copy it from here, and then after this whole email, what I'll do is I'll add the demo experiment here, and if I run this, it should create the experiment. It will first try to locate experiment with this name. If it is not able to find it, it will just create it. Let's wait for a couple of seconds for it to run. So you see this. Please read through these logs, because these are very important logs, and when things go wrong, you need to debug those. So if you come here, you can see that experiment with name this does not exist, creating a new experiment. And after that, it has created one experiment, and it has basically set this thing called artifact location. Now what exactly is being used for artifact? Artifact is essentially a a store for large files and models. So what Databricks has done is it has created this location for artifact storage. Okay, so now what we can do is we can use those experiments. Now that this experiment has been set, what we can do is we can simply come here, and we can log all type of things here. So what I can do is I can do something like with MLflow, and you can see AI is starting its work. So it is basically giving me some sort of suggestion. Now after starting this work, I don't need to provide the experiment, although you can provide it by providing the experiment ID. Now where do I get this ID from? You can see from the previous run also you get this ID. Or if you don't like if you are not available, if you don't have this output ready, what you can do is you can come here into the experiments tab in Databricks, and after that you can click on it, and you can grab the experiment ID from here. So there are a couple of ways. And also, yeah, so this is important piece of choice that you need to make. So in MLflow, experiment can be of either two types. It can be Gen AI based experiments or traditional machine learning based experiments. For now, I'll just click on this. Now, within the experiments, you can have multiple runs. Now, where would you get the experiment ID? So if you come here to the URL after the experiments, you see this number. This is your ID. So from here also you can get your ID. Okay. All right. So let's now move on. So you can specify the ID here, and you can also specify the run name. So I'll specify the run name as first run. Okay, or rather first test run. And after this, would start the MLflow's run context, and within here we can log all sorts of things. What kind of things we can log? I have covered these things in detail in my previous MLflow videos, where we did MLflow locally. Now what we can do is we can test this out really quickly. We can log params, and in the param we need to provide the key value pair, and if you have a dictionary ready, you can provide that dictionary and it will create all the key value as the parameter. It will log all the key value as the parameter. So now in the mlflow.log params, what I can do is I can do something like, maybe you would want to log theta, so I can have that as either string or integer. I can also do log params. In the params I can provide the dictionary. I can say something like alpha, and alpha could be something like maybe 0.33, and I can have something like beta, and I can have maybe 12. Okay, now after logging params I can log metric, and as you can see, the built-in AI auto completion of Databricks is giving me all sorts of suggestions. So I can obviously, if I wish, I can basically hit tab, and I can basically use that. Okay, so I'll just log the accuracy, and then finally I would like to show you how you can log the artifact. Now, since artifact is something that is usually considered large compared to params and metrics, so artifacts are models and files. So now, before logging the artifact, you also should be having artifact, right? So let's create the artifact here. So if I click on it, I can come here and create, and I can create a text file. This will open the text editor, and I can create all sorts of text editors here. So let me create a Python file here. So what I'll do is I'll name this file as sample.py, and here I'll just add bunch of things. Import os dot, or rather print os dot get cwd. Okay, now I can use this file to basically log the artifact. Currently the file is not being displayed here, so I'll just refresh it, and if you can see, my sample.py is here. Now what I can do is I can come here and I can log my artifact, and in the artifact I can provide the path of the file where it exists. I can either provide the full path, or I can, if I am running this notebook from the same directory, I can just provide the name of the file. Now if I hit enter, it should create this run in the experiment called this demo experiment. Now notice here, this nice thing about that Databricks is that after running, it is basically giving you the direct link to access the experiment. So I can click on this right here, and I can close the previously opened one, and once the experiment is opened, I'll see the run, first test run. If I open it, here I should see all the params and logs that I created. So we see accuracy, we see the parameters, and if I come to the artifact, I will see the sample.py file being logged as an artifact here. So I can open it and I can inspect it. Okay, so I think that would be it for this video. In the next video, we will be looking at how we can do manual logging and auto logging using MLflow and using scalar. Thank you so much. Hello everyone. In this video, we will be looking at auto logging and manual logging. And in fact, manual logging is something that we already kind of looked at, because in the earlier discussions, we saw how we can log things using MLflow.log, and then whatever we want to log, that name. So log artifact, log params, and log metric. That we have already seen. So that is a manual logging. Okay. Now imagine that you are basically training a model using sklearn, and you have to log using this method. It will work if you want to have more control over your logging functionality, but then MLflow comes with a flavor specific auto logging functionality. And when I say flavor specific auto logging, what I mean by that is different frameworks have different kind of things that have to be logged. For example, the things that are going to be logged for sklearn models will be different compared to, let's say, PyTorch based models. So that is why MLflow comes in various flavors of autologging. Now let me show you how we can basically take advantage of the autologging. So before doing anything, you might want to set up this experimentation and all. If you don't know, you might have to watch the earlier discussion that we had. So here, if you see, we are logging things manually. Now I need to get some sort of training script. Okay, so what I can do is I can come here, sklearn uh, basic training example. Okay, and it should give me some examples for the training. So I will just grab some examples from here. Let's see. Let's use the classifier comparison, not here, I guess. These are I think this example I can grab. So what I'm doing is I'm loading the iris, so I can just grab this. So now if I just come here to the experimentation and run, and if I run this, you see all of the packages are pre-installed, so it will be already involved. Now you might be thinking that how are they already included. So you can come here and you can click on this button, and you can click on the configuration, and inside the configuration you see this dependency. So you will get this pip requirements file, and inside this sorry, not here but rather here. So what all you need to what all things are already installed for you, you can come here and you can look at that. And if you want to add more things, you can basically add add more packages. Add, you can say, add you can even add your requirement.txt file. Okay, let's come to the topic. So what I can do is I can one by one run this script. So let's run this, and let's load the data. Let's run this, yeah. And after that we can run the third step, that is train test split. And we can fit the model. And notice here, currently I'm not concerned about logging here. Okay, so now if you see, I have achieved the model accuracy of 1.1. Now let me navigate to the experiments. So here is my experiment. Let me go to the experiment. Let me see if I don't have any new run. Why? I was explaining the auto logging, right? But why it is not auto logging? What is happening here? So let's do one thing. Let's run all these cells again. But this time what I'll do is I'll do MLflow dot sk learn dot auto log. One second, auto log. Okay, so let's run this. Okay, so now auto logging has been enabled. Now let's run this again. Now it should log, right? Let's see. Okay, so we should be seeing model accuracy as 1. And let's, after this step, Okay, so we have got k nearest neighbor classifier and we have got model accuracy. Let's refresh this page and let's see if we have got any more run or not. Okay, so we are seeing one run, right? So if I open this, it has created a run called efficient crane, and inside it you see a lot of information like you have got training accuracy, you have got testing accuracy, you have got these params like metrics param and jobs and things like that. Okay, so if I go to model metrics, you will get all these model matrices. You will get artifacts also logged. When I say artifact, you will get the model. So entire model is packaged into a format called MLflow model. You will get model.pickle. So model can be reproduced using different you can say flavors. You have got requirement.txt files to reproduce these things. You will get model.pickle file, you will get conda.yaml file. So all these things you are getting when you do this auto logging. But currently you don't have any control over run, so run gets created automatically. Now what do you think what you need to do to enable this run functionality? So what you can do is you can take this entire thing. So let me not entire thing, but sorry, let me do one thing. Let me now with mlflow.start run, and inside here I'll pass the run name as um, maybe manual auto logging run, auto logging. And then here what I can do is I can do model fit again. Let's try that. And then after that, let's try only model fit, nothing else. So if I run this, let's see what happens. So here I'm not doing anything. All other things are done before this run context. But let's see if we have got any other run here. Okay, it's loading. So we are seeing this auto logging. So you see still, even if I do just the training part here within the auto logging, within this I'm able to get all these artifacts here. Okay, cool. So this is how you do auto logging using MLflow. Now if you had to do, let's say, manual logging, then you could have just done MLflow. Now please be aware that if you do auto logging again and run it again, then there will be one more auto logging run get created. So runs differ by their ID. So you might have to basically grab this run ID, and if you want to basically reproduce this in the same run, so I have to do run id, and inside here I can pass this. So now it will use this run only. Okay, so I can now comment this out because the model is already there. I can do something like log metric, I can do something like extra metric, and here I can do some random values. So if I run this, it should log the extra metric here. Let's see, let's refresh it, and we should be able to see a extra metric. And this is an example of manual logging. You see this extra metric. Okay, so yeah, so now in the next discussion I would like to discuss the concept of nested runs. Okay, so let's continue with that. Thank you so much. So let us talk about how to do a nested runs in MLflow on Databricks. Now, the concept is quite similar as we do nesting locally on MLflow. So let me show you that. The idea is that right now the way we are making these runs is we create a run and we open this run and we see the outputs within that run, right? The idea is that we can have a use case where I might have a, you can say, a parent run, and inside that parent run you have got different experiments. Maybe usually the way this experimentation works is you have a experiment as part of something large. You have some hypothesis that you are testing, and you have got various runs which basically test that hypothesis. Now you can have a situation where you have a hypothesis, and under that hypothesis you have multiple other hypotheses. I hope you are getting the point. You will get it in a moment. So I'll do this MLflow dot start run. Okay, so I'll create this as maybe parent run. I'll name this as parent run, and I'll create this as parent. Now within this run, what I want to do is I want to start one more run. Okay, so with MLflow dot start run, and I would like to name this as maybe child one, child run one. Okay, or maybe child one, and here I need to specify a parent ID. So I'll say parent run ID will be, it will come from this parent. Okay, so I will say parent dot info dot run ID. Okay, so as child one, and here I can do something like MLflow dot log. You can do all sorts of things that we have already seen. So log params, and here I can log my param one. Okay, similarly I can copy this couple of times, and I can do child 1, child 2, child 3. I don't need to necessarily change these names, because I am running this only after this gets executed. So and in this manner you can see, you can create a hierarchical relationship where within the child run also you can have multiple runs. Okay, so let me run this and you will see the output, how it will look like. One second. Why the syntax is wrong? Let me see. Line number 3 syntax is wrong. Why? Okay, I think name is something that I did not correctly specify. Okay, so and after that, okay, so what we can do is we can simply run this, and let's see. Start run got an or run name, sorry, run name, uh, run name, run name, run name. Run with, to start a new run first, and the current run with start a nested run. Oh, okay, I think so. Okay, so yeah, so after specifying the parent run ID, I need to also specify the nested argument, which is going to be true. Okay, so I need to basically get this nested equal to true in all the run definitions. Okay, now let's run this. It's saying, okay, shit, I needed to, so there are a lot of bugs here. Provide this as dictionary, not set. Okay, now it will run. So after this, we will see lot of, because okay, so let's refresh this. Okay, so the only correct run, parent run, would be the latest one. So all these things were created because we were getting the errors. So let's delete this. Now you'll get this parent run, and if I expand this, you'll get child 1, child 2, child 3. Okay, and I can open the parent run also, and I can open their child runs separately. So you get the idea. Like if you have a sub hypothesis, and inside that sub hypothesis you want to try out bunch of parameters, bunch of metrics, and bunch of models, you can try out the nested run functionality of MLflow. So yeah, so thank you so much. Now we will be moving ahead and looking at how model registry and serving of model looks like with Databricks. Let's move on to that. Thank you. Let us now look at how model registration works on Databricks, and it is a little bit different than what we normally do in local MLflow setup. Now on your screen, what you are seeing here is I'm not into the MLflow section, but rather this catalog section. Now this catalog section is where your model will eventually land. Okay, so you can log your models here in the experiments, but eventually if you have to register your model, you need to create those here. Okay, so what I have here is you have got this organization level segregation, and in the organization you have these workspace and system. What are these? These are known as catalog in the Databricks terminology. And if I expand this within the workspace, you see two different what we can call them as schemas. So we have got default schema and we have got information schema. And obviously information schema will have some you can say information related to Databricks, and then there are system specific you can say catalog. So I've got two catalogs here. Sorry, not catalog, I've got two catalog here, workspace and system. If I expand the system catalog, within the system you will see there are some you can say options, like for example MLflow. If I expand the MLflow, within the MLflow, I will have these you can say schemas. Okay, sorry, the schema is MLflow. These are tables. So if I open the experiments latest, this table will have all the details related to my experiments, like account ID, who ran the experiment, what was the workspace ID, what was the experiment ID. Now how can I query it? I can query it in the SQL editor. So I can open this SQL editor in a new line, in a new tab, sorry, and then I can explore this. Now why I'm telling you all this is because here there is a shift in mentality. In your local setup you have everything logged locally, but here these things are being saved in the catalog here. Okay, so now I can see the SQL query. I can create a new SQL query and I can basically run anything that I wish to run. Okay, and you can see I have got these users. Now I have got two users here. One is the user that I added, um, and I have got one more user that I can clearly see here. Okay, so now if I open the SQL query, I can select the workspace and I can select the schema within the workspace. Workspace is where? Workspace is here. In the workspace, I can select what? I can select the default schema. Okay, and within here, so this is what I wanted to show you, is that how catalog looks like. Now let me come to the model part. Now within the catalog, so if I expand the default you can say schema, within this I can create some things. What are all the things that I can create? Let me click on default and let me click on let me come here to the right. So if I click on it, you can see you can create several things. You can create a table, you can create a model, you can create metric view, and you can create volume. For now, let's go ahead and create a model. Let me create a model, and I will create a model with the name, let's say I'll name this model as maybe sample demo model. Sample demo model. Now once I have this model name ready, what I have is so I have got this model available in workspace catalog, default schema, and this is the name. So the way I'm going to refer to this model is I'm going to refer to this model as workspace dot, what is the schema name? It will be default schema, and then I can basically grab this name. So this is the fully qualified name of my catalogs model. Now what is the use of this? So the use of this is let me show you this experiment. So this is the model, this is the notebook that I have. In this notebook I am basically setting up a run, which basically is creating a simple classifier model, and then it is logging the model. Okay, now you can log the model. At the same time, you can also register the model. So these two are different things. Logging model would just log the model and associate that with this run. Let me show you what I mean by that. So I'll say run name is equal to demo registry, or maybe demo catalog. Okay, so let me now do one thing. Let me not register it. Let me just log it. So I'll just run it. This is going to be demo catalog. Let's wait for some time, and meanwhile let's explore this further. So I want to take you to this system catalog, and inside this system AI catalog, in the AI you have got these models. So as I explained you can create models, tables, and variety of things. So I can expand this model, and you see these models are available. What are these models? So these models are LLM models. They are already registered by Databricks. Now, what you can do with it? You can serve these models. How can you serve it? I will show you in later videos or later sessions how to serve these videos. But these LLM models, since these are very huge, Databricks took the effort of basically logging these models and providing you in the catalog. Now what you can do is you can just take these models and basically create the serving endpoints. Okay, so let's see. Okay, so this is completed. Now I can open this in experiment, this run. So let me open this run, and let's see what have we got here. So I see this experiment, we don't have anything, but if I come here in the artifact, I will see this model, right? Okay, so now I'm able to see this model. But if I go into the models tab from the left, I I'm so here if I see, I don't see my model, right? So I do see my sample demo model, but I don't see exactly like so this model is not here in this registry. Now where is this model? This model is only associated with my experiments. Okay, now if I open the sample demo model, it will take me to the catalog where we created it. But currently this sample demo model has no artifact associated with it. Now how can I bring my artifacts to basically to this model? Now I do we don't have anything, like even we don't have the first version. So you see there are no registered model versions yet. We do have the model, but we don't have the registered model versions to it. Okay, so let me go to the experiments again, and under the experiments I will come here into the not demo experiment. Sorry, not demo, but rather this one, because in this notebook I did not refer to any experiment. So now uh, let's let it load first. Okay, so one second, why it is not loading? Okay, so yeah, so this is the experiment name. When you don't specify the experiment name, it will refer to the notebook name. Okay, so now after that, it is loading the run. So we have demo catalog, and if I go to artifact, I have this run. Now if you see this register model, you can either register it from here, or you can from here you can provide the register model name. Register model name argument. And how are you going to provide that name? You will provide it by specifying three pieces of informations. Okay, first one is going to be catalog name, second one is going to be schema name, third one will be the model name. So if you provide all these three names, it will take this model artifact associated with this run, and it will put it inside this model. Let's do it from here. So I'll click on this registered model, and then I need to select which model I will be using. So you have got several models here, so you can choose any model that you wish, but we created the sample demo model for this, and I'll register it. And the moment I register it, it started registering run this. Now if I come here and if I refresh it, so I'll just see by refreshing whether my sample model has been basically a new version has been created or not. Okay, so currently we don't have any versions yet, But let's wait for some time and let's see how long it takes. But this is the process that I wanted to show you, like how cataloging works, and how catalog is actually different than how we do modeling in like locally. Okay, so let's refresh it again and let's see if it does not happen this time. I'll just pause this video and resume it once we have this registration completed. Okay, so we have the registration complete. You can see now version 1. So if I click on version 1, I will be able to see the model artifact paths. Now once I go here, I can click on the serving also. Like let me show you 1 second. So yeah, so from artifact I can look at the exact models that basically got created here. Okay, so with that said, I think that would be it for this video. Now we are going to be looking at how to serve a registered model using Databricks managed serving endpoints. Thank you. Hello everyone. So in this video, we want to look at how we can actually take our registered models and create the endpoints. Now I went ahead already and created one endpoint. Already, because it takes some time to container to spin up and actually start serving our models. But let me meanwhile, while this is being created, what I want to do is I want to do couple of things. First I will show you how when I click on this create service serving point, how does it look like, and then we will be reviewing this endpoint, and then we will be try to use this endpoint. Okay, so I think there are a lot of things that we need to do. Let's get started. So there are two different ways by which we can create these endpoints. First is we can go inside the navigate to the models, and we can choose the models that we want to create the endpoints for. So for example, if you want to deploy the Claude Sonnet 4, you can click on it, and then you can come to this top right button that is serve this model, and if you click on it, it will automatically take you to the serving page, and it will ask you for some parameters like what will be the name of the output, name of the endpoint, and then entity details. And also for your information, in Databricks, entity is known as anything that is there in the catalog. So catalog can have tables, and it can have models, and it can have other things also. So and that follows this pattern, that is catalog dot the schema dot the name of the entity. Okay, so this is how you create the endpoint. So you can obviously specify the name, and you see this URL format. It will be HTTPS by default. So yes, your endpoints will be secure, and then there will be a user ID. So user ID will be depending upon what your user ID is, and then there will be .cloud.databricks.com, and then serving endpoints, and then whatever name you specify here will come here, and then invocation. Okay, so this endpoint, if you hit, you can call these models whatever you want to register. So let's try to basically let's go inside the models again, and let's open the sample demo model, uh, and let's see when I so what I can do is I can serve this model. I can click on it and serve this model. I can then it will take me to the serving page as mentioned. I can have maybe a sample model, and then after that it is automatically basically filling the compute type. But depending upon the kind of usage you are dealing with, you can select GPU or CPU. You can select GPU small, GPU medium, and GPU large. And then there are these concurrency settings which you can basically select. You can select whether you want to scale out or not, and what will be the minimum concurrency, what will be the maximum concurrency. Okay, now you can also enable this scale to 0. I have enabled it in my previous serving that is currently in progress. We can enable the tracing also. It will basically track all the input output, and it is going to save this into your catalog. Then you can do the route optimization, and we can do that using AI gateway. So we have got under the AI gateway we have got enable usage tracking. We can enable inference tables, and we can also select the table location. So I can select the catalog, I can select the schema, I can select the table prefix, and then we can obviously go ahead and create some tags, serverless usage policy, and then we can get some sort of alerts. So we can configure let's say email alerts, and on success or on failure, if you want to create the alerts, and then finally you can click on this create button, and it will basically start the serving process. Okay, now if I look at my previous endpoint which I created, now it's ready for usage. How can we use it? But before even using it, I want to review some of the settings. So you can see, as previously, the endpoint is this https secured version, then my user id cloud.databricks.com, serving endpoints, my first endpoint, and then invocation. So after this, I can also look at my usage policy, like how it is basically um, performing. And so for example, if I can look at my latency. So Databricks is a complete end-to-end, you can say, monitoring and observability stack for you. MLflow is inbuilt, so all these things you are getting by subscribing to one tool. All right, so after this is done, what we can do is we can obviously delete it, but let's try to use this. So how are we going to use it? We can use it via curl, you can use it via python. So let's try to use it via python. So I'll just copy this command, and I'll come to my notebook. Let me also save this notebook, maybe. uh, Log and register model. Okay, so let's do one thing. Let's use it here. Let's try to use it here only. So we are importing OS request, and then create tf serving JSON, and then we have this URL authorization. I'm getting this Databricks token. Where is this Databricks token is going to come from? Let's see. One second. Okay, I think it will automatically for secure Unity catalog connection securely. Okay, data frame dot split. So where exactly is my token is going to come from? So let's see. So I did some digging. So this is where we can get the authentication tokens, by coming to the settings. So I can go here and then open my settings, and inside the settings I can basically get the token by coming in the developer panel. I can click on manage, and I can generate a new token. Maybe I'll set the lifetime to 1 day, my token, and I'll generate it, and then I'll just grab this and I'll paste it here. So I won't be using environment variables for that, but you should probably use that. Okay, so now this is our the token. The content type will be JSON. Then we have got dataset dot to dictionary dot orient dot split. So now I would want to basically first of all run this, and then I will take my x. So I will look at my x the way x looks like. So currently x is like this. So what I want to do is I want to score model, and I would want to provide my x here. So let's run this, and let's see what do we get. So what we are getting here is we are getting predictions, and the predictions are coming in a dictionary of list. So predictions.list. So it has scored all this into this JSON, and it has returned this. If I come here, I should be this graph should be updated. Let's refresh it, and let's see if we have got the latency numbers. So we did get the CPU usage, we did get the memory usage, we got provision concurrency also, but the latency is something that we haven't received yet. Maybe it will take some time, but anyways, see, the point that we wanted to make by creating this endpoint is how it would look to deploy one registered model via Databricks. Now this endpoint, if let's say this token is still valid by the time I upload this video, you can make calls to this URL. So this is really powerful. Now you are no longer creating these endpoints locally as we do using MLflow's open source. We are creating it using Databricks managed. Okay, so I think that would be it for this discussion. Now we will try to look at some of the GenAI stuff using Databricks. So thank you so much.